ओके, तो आज हम वर्क डन पे थोड़ी बात करेंगे। हाउ टू कैलकुलेट द वर्क डन मैथमेटिकली, फॉर्मुलेशन करेंगे उसका कि कैसे फाइंड आउट कर सकते हैं। तो वर्क डन का फॉर्मूला हमने बहुत पहले ही पढ़ चुके हैं हम, लाइक इन आवर high school classes also we have seen the formula, that is work done equal to force into displacement. But the important thing is that this force is the uh, same force, I mean the same amount of force. That force is pre-existing, पहले से ही वो उस सिस्टम पर अप्लाई हो रहा है. What do I mean by that? Suppose I am having a block of mass m placed on the surface of earth. तो इस ब्लॉक पर ऑलरेडी कौन सा फोर्स एग्जिस्ट कर रहा है? ग्रेविटेशनल फोर्स, राइट? एंड नाउ इफ आई ट्राई टू मूव दिस block with a distance h, right? Then what amount of force I need to apply in order to lift it up? Same force that the gravitational force is acting there, right? Mg. And that is the force, and displacement is h. So hence the work done is mgh. So the important thing is that we need to do work against the pre-existing force. Fine, this concept is important. Now suppose now we go for the thermodynamic system. I am having a cylinder piston system uh, where we have a gas inside this cylinder, and there is a piston. There is a piston. Fine. Okay. So important to notice, first of all, there are few technical points here. The area of piston is equals A. Fine. We will see why are we writing this, because it will be important. Now can you tell me what is the existing force here? It is the same existing force, kind of the gravitational force, or the force due to the atmospheric pressure. This is the force due to the atmospheric pressure. So there is atmospheric pressure from environment, P external. So whatever the mass of the area, the mass of the air above this cylinder is there, so that mass is exerting the mg amount of force in this in this piston, that is called the pressure, atmospheric pressure. So suppose that external pressure is P ext. I am writing it by this P ext, and we want to find out the work done, right? Work done. So what and we know the relation between force and pressure, because we need force for the work done. This is the very fundamental definition of the work done. We need force, but here we are given the external pressure. Fine. And important to think about this, that because the pressure may change with height. At this height pressure is something, at this height pressure is something different. Okay, so let us suppose that this pressure has, external pressure has moved the piston by small amount of ds. This is the small displacement in the piston. So we can say that this amount of the ds height of the gas has been compressed. You can say in that way also. Okay, so what is the small infinitesimal amount of work? dw equal to fds. And since force and displacement in the same direction, so you don't have to worry about the angle. And we know that the force is nothing but pressure into area. What is the pressure here? P external, and area is, this is why I have written the area in advance. So P external times area into ds. Now can you tell me what this thing is? A dot A into ds, area into in small displacement, that is nothing but the small infinitesimal volume. A ds equal to dv. So the infinitesimal work comes out to be P external times dv. This is the formula for infinitesimal work. And of course, if you want to find out the total work, then you need to see that what is the final volume and what is the initial volume. So you can integrate it from V initial to V final. That is the total work. But important thing to remember, whenever the concept of work done comes, then you have to mention, you have to be careful about work done by whom. वर्क डन बाय होम, कौन सा फोर्स यहाँ पर वर्क डन कर रहा है. इफ यू रिमेंबर द काइनेटिक थ्योरी ऑफ गैस लेक्चर्स, the pressure of the gas is also there, right? The gas molecules exerts the pressure on the walls of the container as well as the wherever it can collide. So the pressure that is inside the gas, right? So we can show it by like this. This pressure, this is the pressure of gas from lower to or downward to upward direction, like this you can say. So that is another pressure. It is also exerting the force, but we are not caring about that force right now, but we are just caring about the force by external force. So this is very important to mention, that this work is done by surrounding. Surrounding means anything that is outside this gas, because the gas is the system, right? And we have seen the definition of surrounding is something that is not the system. Everything outside the system is called surrounding. So whatever was outside the gas is the surrounding. That is the work done. Sorry, that surrounding is doing the work done here, right? So if you see that this work done is depending on the external pressure, and we don't know what is the external pressure, right? Because in many times we don't know what is the external pressure, and external pressure is not in our hand. So we need to modify this formula, because if you want to study the system, then you should have the control on the system only, right? You know about the system, you know the macroscopic coordinate of the system, but you don't know anything about the surrounding, because your interest of study is the system, not the surrounding. So this formula is okay, but it is not beneficial for us, because we are studying the system. So here comes the role of reversible process. Reversible process, we have seen in the reversible process, each and every step between the process is the each and every state through which system passes is very close to equilibrium or almost in equilibrium. An important thing to remember, I have forgotten to mention this thing during the reversible process, that it is in equilibrium, but equilibrium with whom? Equilibrium with surrounding. So what was the definition of reversible process? In the reversible process, the system passes through the equilibrium states, and that equilibrium is with respect to surrounding, meaning whatever the temperature is of the system is there, the same temperature of the surrounding is also there. Whatever will be the pressure of the system, that will be the pressure of the surrounding. So that is the meaning of equilibrium. So irreversible process that you already mentioned, that states through which system passes are very close to equilibrium. Okay, equilibrium with surrounding. It is important to mention. ये मैं लास्ट टाइम बताना भूल गया था. सराउंडिंग के साथ इक्विलिब्रियम पर रहेगा. इसका मतलब क्या है कि P एक्सटर्नल विल बिकम P गैस, प्रेशर ऑफ द गैस, फॉर all value of volume. This is the meaning of, or temperature. This is the meaning of reversible processes. So now you can use this formula again, and since for reversible process the P external equal to P gas, then you can replace this thing, P external by P gas. But mind you, you need to keep this thing in your head, that this is valid only for reversible process. Only for reversible process. Whatever you have seen in your classes, the master, I don't know, the teacher has mentioned this point or not. They people casually write this thing, W equal to PdV, but this P is always the pressure of gas in their notation, and this they never mention that this is only valid for reversible processes. And in general we don't write gas here, so we just write PdV, but fine, you can take these things in your back of the mind. Okay, so now you can see that this pressure is the property of system, because this is the pressure of the gas. Okay, so now we have control on this pressure. So this is how you will calculate the work done in the work done by the gas. Fine, that is there. And you need to write one more point, key at every point during the process, reversible process of course, P surrounding, pressure of the surrounding is equal to pressure of the system, and temperature of the surrounding equal to temperature of the system. Okay, and you should have a question like why it is applicable for only reversible process. Because if you see, you are integrating from V initial to V final, and what is the meaning of integration? Integration is the summation, right? So at every point you need the value of V, है ना. मान लो वो V इक्वल टू V0 से V इक्वल टू 2V0 तक गया, तो ये जो बीच में जितने भी वैल्यूज होंगी उन सारी वैल्यूज के बारे में इंफॉर्मेशन हमें पता होनी चाहिए. दैट इज़ वाई वी नीड reversible processes, and only in the reversible process we know the value of the thermodynamic variable in between the process. Okay, fine, that is there. Now so साइन कन्वेंशन इज इम्पॉर्टेंट, तो उसको डिस्कस कर लेते हैं पहले. तो you have to be very very careful about the language of the question. So whenever they say work done, just work done mention किया गया हो, या फिर उन्होंने explicitly mention किया गया हो work done by system on surrounding, ठीक है. अगर ये दो चीज़ें यूज कही गई हो तो ऑलवेज यूज दिस फॉर्मूला, W इक्वल टू प्लस PdV. फाइन, ओके, दिस इज द फर्स्ट कन्वेंशन. एंड सेकेंड कन्वेंशन इज, अगर लिखा गया हो वर्क डन बाय सराउंडिंग, वर्क डन बाय सराउंडिंग ऑन सिस्टम, सिस्टम पर किया गया हो, देन यूज जस्ट W इक्वल टू माइनस PdV. सिंपल. अगर ये दो कॉन्सेप्ट क्लियर हैं तेरे को, तो नाउ यू विल हैव नो कन्फ्यूजन एट ऑल. बस ये दो चीज़ ध्यान रखना कि एक जगह प्लस यूज़ करना है, एक जगह माइनस यूज़ करना है। अगर सिस्टम के द्वारा काम किया जा रहा हो तो प्लस, सिस्टम पर काम किया जा रहा हो तो माइनस, दैट्स इट। नाउ वन मोर इम्पॉर्टेंट थिंग इज दैट कि we have seen that we have seen those indicator diagram, right? Indicator diagram, of course we have seen those indicator diagram. So if we have PV diagram, for PV diagram, the area under the curve gives the work done during the process. ठीक है, तो suppose this was the PV axis and the process is like this, something from initial point to final point. And so the area under the curve will be like this, of course, no doubt on it. Fine. So this area, whatever will be this area, that will be the work done. We don't know this is work done by system or surrounding, that is a different story, but the area under the curve is going to be the work done. Why? Because we know the by mathematics area is nothing but here integral PdV. In mass, whatever the what is the area, y dot y into dx, right? In the y-axis we have here pressure and in the x-axis we have here volume, and this is what we know, the area, and same is the formula for work done. Fine. And from here you can see that clearly the work from the graph also, from the PV diagram also, we can see that work done is path dependent. Why? Suppose if you see the PV diagram and you have to go from point, suppose initial point to final point, suppose like this, like this, but you go from initial point to final point in two different ways. How? Suppose you go directly like this, this is the one way you can go, and I'm giving you another way like this way, then this way. Okay, two different paths are there, no doubt. Fine. Now can you see the area under the curve? You can see this is the area under the curve here. What is here the area under the curve? This one only. So you can see now the area under the curve is different, hence the work done is different, hence the work done is path dependent. So कौन सा पाथ हम ले रहे हैं वो पाथ पर डिपेंड करता है कि वर्क डन कितना किया गया है। वो वर्क डन सिस्टम द्वारा किया जा सकता है, सिस्टम पर किया जा सकता है, दैट इज अ डिफरेंट स्टोरी, दैट विल बी गिवन इन द क्वेश्चन। ओके, fine. Now from this graph also you can see a very interesting things. Suppose there is a complete cycle of the work, so the heading is work done in a cycle. Fine. So and cycle means that there will be a loop of PV diagram, Okay, so suppose this was the initial state, not position here. Indeed, this is thermodynamic system, and this system has gone through this process from initial to final state, and then it has come to final to initial state like this. Okay, fine. So the arrows are important so that it can tell you the process, how the process happened, right? So if you see, this process is actually this process is and clockwise, not anti-clockwise. This So this is the first case for the clockwise cycle. So if you see, for initial to final point like this, what is the area under the curve? This one, this one, right? This one is the area under the curve. What is the area under the curve for this one, final to initial? Only this one, right? So if I say area under the curve, AUC, for initial to final is A1, suppose, and area under the curve for final to initial was A2. Okay, and we know that these area means work done. Okay, so what is the correct relation here? A1 is greater than A2, A1 is less than A2, or A1 is equal to A2? Tell me. Pause the video and think about it. Area under the curve, this is the initial to final process, so this is the area under the curve. For final to initial state, this is the area under the curve. So the question is that which area is higher, bigger? Of course A1 is greater than A2. Fine. Okay, so clearly we know that the A1 is greater than A2. Fine, good. Now tell me, work done by gas or system. We know that we need to use the plus wala formula, P into dV. Okay, this one. And we know that initial to final position, first we have to see initial to final position, what is the work done by gas. So of course the V final is greater than V initial, है ना, क्योंकि ये V final यहाँ पर है, V initial यहाँ पर है, ठीक है. And pressure is always positive, right? Pressure is always positive. So अगर ये जो ये फाइनल वॉल्यूम एंड इनिशियल वॉल्यूम में ये रिलेशन है, तो ऑफकोर्स दिस वर्क इज पॉजिटिव. ओके, रिमेंबर दिस इज वर्क डन बाय gas, that is why we have used the positive sign. You will be trapped if you do not care about the work done by whom, gas or the surrounding system or the surrounding. Now if you see from final to initial situation, what is the work done by system, and we are just caring about the system right now, so it is of course plus PdV. But now if you see the V final and V initial relation is reversed, because for this process from here to here, if you see finally the volume has decreased, right? Initially the volume was this, now finally have volume decreased, so this is negative work. Okay, fine. So what do we see? That this was A1, right? And this was A2. And we have seen that A1 is greater than A2. A1 is greater than A2, and A1 was positive and A2 was negative. So overall, this total work, total work क्या होना चाहिए? A1 plus A2 होना चाहिए था, बट A2 तो नेगेटिव है, तो यानी कि A1 minus A2 होगा, राइट? And we see that A1 is greater than A2, hence the total work is positive. सो यहाँ से जो कंक्लूजन निकल के आता है वो ये निकल के आता है, फॉर एंटी क्लॉकवाइज साइक्लिक प्रोसेस, वर्क डन बाय गैस और सिस्टम इज पॉजिटिव। मीनिंग कि सिस्टम हमें कुछ काम करके देगा, सिस्टम हमें कुछ काम करके देगा, ये है इसका मतलब। और इसीलिए अगर तुम देखेगा तुम्हारा जो हीट इंजन होता है, कार्नो साइकिल जो होता है, वो एंटी क्लॉकवाइज होता है। सॉरी, दिस वाज क्लॉकवाइज क्लॉकवाइज होता है, राइट। अगर तू कार्नो साइकिल देखेगा तो उसका जो साइकिल बनता है वो क्लॉकवाइज बनता है। That was the point here. For clockwise cycle, the work done by the gas is positive. And if you see the anti-clockwise case here, if the cycle is anti-clockwise, second case, so suppose this was the initial position and this was the final position, right? And then it goes like this. So this thing is this cycle is anti-clockwise. So now if you see from initial to final position, what is happening? Volume decreases, है ना? V final is less than V initial, implies that W is P dV because work done by the gas is positive, प्लस साइन के साथ लेते हैं हम, तो ये चीज़ क्या निकल के आ जाएगी? नेगेटिव निकल के आ जाएगी, है ना, क्योंकि dV इज नेगेटिव। तो पहला वो होगा, यानी कि W1 इज नेगेटिव। Similarly, if you see for the final to initial position here, volume increases, meaning dV is positive, यानी कि V final minus V initial is positive, implies that W2 is positive, right? अगर एक नंबर पॉजिटिव है और एक नंबर नेगेटिव है तो इनका नेट, इनका रिजल्टेंट क्या आएगा, वो डिपेंड करता है कि कौन सा, किसका मैग्नीट्यूड बड़ा है। तो इफ़ यू सी द एरिया फॉर W1 इज दिस, area for W2 is this. So of course the magnitude of W2 is less than the magnitude of W1, therefore the network W total is negative. Think about it, it's too easy to think about it. Okay, so this is why we say that in clockwise, anti-clockwise cycle, cyclic processes, the work done by the gas on surrounding is negative. Okay, so these were two important cyclic processes, clockwise or anti-clockwise. In clockwise cycle, the work done by the gas is always positive. And what does it mean by positive here? Positive का मतलब है कि सिस्टम हमें काम करके देगा, और यही तो इंजन का काम होता है। इंजन का काम क्या है? हमें इंजन से काम निकालना है, इंजन हमें हेल्प करे, इंजन हमें एनर्जी दे, मतलब कन्वर्ट करे एनर्जी को, एनर्जी कन्वर्ट करके कुछ काम निकाल के दे, तो इसीलिए वो पॉजिटिव होता है। और इसीलिए उसका साइकिल भी, कार्नो इंजन का साइकिल भी पॉजिटिव होता है। पॉजिटिव मतलब क्लॉकवाइज होता है, वर्क डन पॉजिटिव होता है, वर्क डन बाय द गैस। ओके, अगर इतना सारा क्लियर होता है, सो नाउ वी कैन गो फॉर डिफरेंट काइंड ऑफ प्रोसेसेस। isobaric, isothermal, right? And these are very simple, very trivial thing to discuss. So suppose if I am talking about isothermal processes, बिकॉज अगर हम द थिंग इज़ दैट इसको समझना इंपॉर्टेंट इसलिए है कि मान लो मैं मेरी थर्मोडाइनमिक स्टेट यहाँ पर थी इनिशियल पोजीशन, और मैं पीवी डायग्राम बना रहा हूँ, और मेरी फाइनल स्टेट यहाँ पर मैं पहुँच गया हूँ. सो नाउ आई कैन हैव मल्टीपल वेज ना, मैं कैसे भी जा सकता हूँ, यहाँ ऐसे भी जा सकता हूँ, ऐसे भी जा सकता हूँ, ऐसे भी जा सकता हूँ. सो देर आर सम वेरी स्पेसिफिक प्रोसेसेस इन विच thermodynamic quantity or coordinate remains constant. So suppose मैं इनिशियल पोजीशन से फाइनल पोजीशन तक जाता हूँ such that the temperature remains same. Initially and finally temperature remains same. Okay. और throughout the process the temperature remains same. तो उस केस में वर्क डन क्या निकल के आता है, क्या निकल के आएगा? ध्यान रखना, अगेन वी आर अज्यूमिंग दैट ऑल दीज प्रोसेसेस आर reversible processes, then only we can use the formula of PdV. So assuming the process is reversible, okay. The word iso का जो ये ग्रीक वर्ड है, इसका मतलब होता है something that is constant when not something if इसका मतलब होता है कांस्टेंट या सेम दैट डज नॉट चेंज. ओके. थर्मल का मतलब जो थर्मल हीट और एनर्जी के रिगार्डिंग हो, तो ऑफकोर्स ये जब टेम्परेचर फिक्स होता है वो प्रोसेस है जहाँ पे टेम्परेचर थ्रू आउट द प्रोसेस इज कांस्टेंट, दैट प्रोसेस इज कॉल्ड isothermal process. When temperature of system is same throughout the process. Okay. So what will the work done in that case? P into dV, of course. वर्क डन बाय द गैस. अगर हम पॉजिटिव यूज करें तो हमेशा वर्क डन बाय गैस निकल के आएगा. एंड सिंस दिस इज रिवर्सिबल देन ओनली वी कैन यूज दिस P. P इज द प्रेशर ऑफ द गैस, ध्यान देना, नॉट द एक्सटर्नल प्रेशर. नाउ द थिंग इज दैट क्या अब हमारे पास यहाँ से हम आगे कैसे बढ़ें, इस वाले लोकेशन से हम आगे कैसे बढ़ें, क्योंकि ये हम इंटीग्रेशन कर रहे हैं एक वेरिएबल और दोनों वेरिएबल अपने आप में लिनियरली हमें लगता है कि आपस में रिलेटेड है नहीं अभी फ़िलहाल, क्योंकि P एक प्रेशर अलग वेरिएबल है और V अलग वेरिएबल है, तो इसको इंटीग्रेट कैसे करें? तो डू वी हैव एनी रिलेशन, एनी इक्वेशन दैट कैन रिलेट प्रेशर, वॉल्यूम एंड टेम्परेचर? जैसे हमारे पास कैनेमेटिक्स में इक्वेशन ऑफ मोशंस होती थी जो एक्सेलरेशन को वेलोसिटी से जोड़ सकती थी, डिस्प्लेसमेंट से जोड़ सकती थी. ऐसे ही अगर हम मैकेनिक्स में जाएं तो वहाँ पर फोर्स जो हमारे एक्सेलरेशन के साथ जोड़ सकता था, मोमेंटम के साथ जोड़ सकता था. सो डू वी हैव सच काइंड ऑफ इक्वेशंस हियर? And we have here that you must have seen in the KTG, the kinetic theory of gases, and that is the ideal gas equation, and that is also very specific kind of relation. Okay, so important to remember here, we know that for ideal gas P equals or PV equals nRT. But remember, this is only valid for ideal gas. Okay? If the gas or the system, है ना, हमने बोला कि सिस्टम हमारा गैस ही होगा मैक्सिमम टाइम इस कोर्स में, तो जो गैस जो होगी आइडल गैस होगी. और आइडल गैस क्या होती है, उसकी क्या प्रॉपर्टीज होती है, यू मस्ट हैव सीन द KTG और यू विल लर्न इन द KTG. तो एक स्पेशल काइंड ऑफ गैस है, इनफैक्ट आइडियल गैस है, तो जो एग्जिस्ट ही नहीं करती रिलेटिवली, बस जस्ट वी लर्न दैम सो दैट वी कैन हैव सम, वी कैन ड्रॉ सम कंक्लूजन्स. ओके, सो इन दैट केस यू कैन यूज द PV, the value of, you can replace the value of P from here like this, nRT by V, right? So nRT by V into dV, and since temperature is same, n and r are same, so you can take them outside, so it will become dv by v. This is w, and v initial to v final. You can integrate it out like this, and then it will become nRT log v final by v initial. Okay, so this is very trivial to find out. This is the work done by nRT ln vf by v initial. But remember, again and again I'm emphasizing the same point, that this is the work done by only which kind of gas? Ideal gas. If the gas is changed, suppose the gas is some real gas, है ना, if the gas is some real gas, and we have some kind of real gas also, maybe that can be in your syllabus or not, I am not sure. So in that case, this equation will completely change. Okay, can you guess where the change will occur? The change will occur here, the relation of P that we have replaced here, like nRT by V, it is specifically true for real gas, ideal gas. If there is some real gas like वंडरवॉल गैस होता है, अगर उसके लिए रिलेशन कुछ अलग होगा, अगर ये रिलेशन अलग होगा, तो यू नीड टू पुट दैट रिलेशन हियर. Okay, this whole expression will change, and this will not the answer then. So remember, this is only applicable for real gas. This is the work done by whom? Ideal gas, because we have used the positive sign. If we had used the negative sign, it would have been the work done by surrounding. Fine. So this was the one kind of processes. Okay, the next process is the isobaric process, and of course you know the meaning of the bar is the unit of pressure. So if the pressure is constant during the process, then such kind of processes are called isobaric processes. So there is nothing interesting in it, I mean new concept to learn here. So when pressure of system is same throughout the process, that kind of process is called isobaric processes. So what is the work done then? The W equal to P times dV. So if pressure is fixed, so you can pick out the P outside, then dV. And if the V is from V initial to changing from V initial to V final, then you can write out V final minus V initial. So clearly this is the work done by gas from V final to V initial. And of course this is applicable for any kind of gas. Why? Because you haven't used any special relation for P, right? That is important. Valid for any kind of gas. Okay, fine. And what about isochoric process? Isochoric process is the process in which the volume of the system is fixed throughout the process, and in that case W equal to P dV. If there is no change in the volume, so this dV itself is 0, so the work done is also 0. And of course it is too trivial to think about it, हाँ, क्योंकि क्या है कि अगर वॉल्यूम ही चेंज नहीं हो रहा है, जैसे हमने ये पिस्टन देखा था, सिलेंडर पिस्टन देखा था ऊपर, दिस, अगर ये जो इनिशियल वॉल्यूम मान लो यहाँ पर था, अगर ये वॉल्यूम ही चेंज नहीं हो रहा है, तो वॉल्यूम कैसे होगा? ना कोई फोर्स लगने के बाद भी अगर ये कुछ डिस्प्लेसमेंट ही नहीं हो रहा है ना, इसका मतलब सिस्टम का कुछ डिस्प्लेसमेंट ही नहीं हो रहा है, तो वर्क डन भी तो नहीं होगा ना. ये थोड़ा सा फिजिकली इसको समझना आसान है. ओके, एंड इफ यू try to plot these kind of process in the graph, in the indicator plot, so how will you draw them? Of course you need to see that कि तुम x axis और y axis में क्या लेना चाह रहे हो. अगर ये pt ग्राफ होगा या pv ग्राफ होगा, तो वो डिपेंड करता है कि तुम्हारा ग्राफ कौन सा वाला है. अकॉर्डिंग टू दैट यू कैन ड्रॉ द ग्राफ. अगर ये पी वी ग्राफ है तो क्लियरली यू कैन सी दिस, यू कैन यूज दिस इक्वेशन बिकॉज टी इज कॉन्स्टेंट एंड दिस इज पी इज 1/v टाइप, सो इट इज हाइपरबोला, रेक्टेंगुलर हाइपरबोला, सो द ग्राफ विल बी लाइक दिस, है ना। और अगर तुम यहाँ देखो पी वी डायग्राम, so since the p is constant, है ना, so the graph will be like this. You always remember the arrow, you can make the arrow. What about isochoric process? Remember I am just drawing pv, it can be tv, है ना, tp, anything, then according to that you can make the graph, this kind of graph. So I am going from initial position to final position in this way. Here also I am going from initial position to final position in this way. I could have gone in this way also, but it's my choice कि कैसे जाना है मेरे को वहाँ से वहाँ तक. So what we have seen that for isochoric process there is no work done by system on surrounding. I hope this is clear. तो अगर मैं थोड़ा सा तुझे एक एग्जांपल देना चाहूँ कि ये कैसे होता है, दिस थिंग, ये जो मैंने बताया ना कि पी जो प्रेशर का हम जो रिलेशन यूज़ कर रहे हैं, दैट रिलेशन इज़ फॉर ओनली वैलिड फॉर व्हेन वी आर डीलिंग विद आइडियल गैस. लेकिन 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 अगर मैं एक ऐसी गैस दे दूँ जिसमें ये वर्क ना कर पाए तो कैसे करोगे उस चीज़ को? लेट मी सी वन एग्जांपल. आई हैव डन इट समवेयर बट आई एम नॉट गेटिंग इट. या example, a gas following the relation P equals A plus BV, where A and B are constant and V is volume of the gas. Of course P is the pressure. Now find out the work done from this P1 V1 to P2 V2. This is the initial state and this is the final state. Okay, fine. So how are you going to use this formula? Again, just work done बोला है तो work done by system, so you will use this formula plus PdV, sorry, W equal to PdV. Now you know the relation, you have given the relation, you are not allowed to use the equation of gas for ideal gas, no, because whatever you have given P equal to A plus BV, you have to use that only. So you replace the value of P here. Okay, now you can see the whole integration has converted into only single variable, है ना, single variable में convert हो गया. तो you can integrate it from what is the initial value of V and what is the final value of V. Simply initial value of V is V1, final value of V is V2. Initial value of V1 is V is like this and V2 is like this. So simply the integration will be V times V1 V2 plus B V square by 2 V1 V2, and this answer is now V2 minus V1 plus B by 2 V2 square minus V1 square. This is the work done by the gas from V1 to V2. I think this is correct calculation. Let me see. या फाइन। तो ऐसे हम कर सकते हैं इसको। तो ये गैस आइडल गैस नहीं थी, तो इसलिए हमने यहाँ वाला ये वाला रिलेशन यूज